Welcome to Cannon's TV.
How are you today? Today we are going to be learning a little bit more science, but we are also going to have fun and make a lava lamp. So to make a lava lamp, the things you will need are a glass jar of some sort, preferably a mason jar, but we don't have that, do we? So we're going to use a jar that we got for Daddy for Father's Day. You need equal parts water, equal parts
Of tubers.
of oil,
Yep.
vegetable oil.
Yeah, that's
For today's purposes, we're going to do 1 cup of each. You need some food coloring. We're going to use red because red is somebody's very favorite color.
And my second one is blue.
And his second favorite color is blue. And to make the fizz, you need Alka-Seltzer tablets. But to begin, we want to make sure that we understand why the water and the oil do what they do. So what we know, have you guys ever heard the phrase, oh, they mix like water and oil? And we know that means they just don't get along very well. And that's because of something very interesting that happens with water and with oil. You see, water is what is made up of what are called polar molecules.
Yep.
Polar molecules have a positive end and a negative end, and it means that they bind together really smoothly and really closely, and they make really, really good friends with each other, and they have a super tight bond. Oil, on the other hand, is made up of what is called nonpolar molecules.
Yep.
As such, what we know is that polar molecules bond really well with other polar molecules. For example, sugar. Sugar is also a polar molecule, but it does not always mix well with nonpolar. To show what that really looks like, we're going to add some red food coloring to our water. Should we make it a dark, pretty red?
Yes.
Okay, get your spoon. Cannon's going to use his spoon and he's going to mix it up.
My handy dandy spoon.
Ooh.
My handy dandy spoon power.
Handy dandy spoon power. Let's get it all mixed up.
That looks like a red blood.
Oh, it kind of does. It's kind of bloody. Okay, so let's take this and we're going to sit it off to the side. Now we're going to take our vegetable oil. Do you want to help me pour it in?
Yeah.
Okay. Pour it in.
How does it not turn the red to like that color?
Well, let's watch and see.
Whoa, look how the red is dissolving like that.
So, Cannon, let's talk about what you notice in this jar. Where is all the red at? Can we look down?
At the bottom.
It's at the bottom. Do you
And-
remember what we put the red into first? What did we pour the red food coloring into?
This jar.
This jar, but what was in the jar at the time?
The vegetable.
It wasn't in there yet. What was in there first?
Um,
The water, remember?
Yeah.
So when we poured it into the water, you can see that it got really, really tight-knit bond because, again,
Look how flat this red is on the top.
I know it looks crazy, right? And then at the top is going to be the oil because, again, the vegetable oil is made up of nonpolar molecules, right? Now, what we do know is that it can mix for just a minute. So if we were to mix it up, mix it up, mix it up, mix it up, mix it up. Oh, let's mix it good, Cannon. Look, what happened?
It turned back to red.
It's all red. It's all mixed up, but let's watch it.
Look
what's
how-
happening.
Look, it's dissolving in there.
The red is going away. So what's happening to the oil and the water?
I don't know, turning into lava.
We're going to make a lava lamp, sure. So what you'll see is that even if you mix it for just a little bit and sit it back down, eventually what we notice is that the water and the oil are going to separate again and again and again. And that's due to the type of molecules that exist in water and in oil. Now, that is the sciencey part, but we're going to do a little bit more fun science once it gets a little bit more separated. What you're going to need for this next part of the experiment is you are going to need Alka-Seltzer tablets. Here, right here. All right, so before we put it in, let's talk about what these are. So what we know about Alka-Seltzer tablets is that they are made up of something called sodium bicarbonate. I had to look at my notes to make sure I was saying it right. And what we're going to see happen is something really cool when we drop those into our mixture of water and, just a second, we're going to wait for just a second and let it separate a little bit better before we do this because we really want you to see some really cool things that happen. Okay, and we're back, and you can see that the separation of the oil and water is still happening. So this next part of the experiment, what we're going to do is we've taken an Alka-Seltzer tablet and we're going to break it into 4 little pieces. But not yet, it's already broken, just a minute. And so what we know about the Alka-Seltzer tablets are that they are made up of sodium bicarbonate and dry citric acid. So one is an acid, one is a base. And so what you're gonna see is the way that it reacts with our solution we've built here is it's going to catch on some of the water at the bottom, and let's see what it does, because it's going to create carbon dioxide, and let's see what that looks like. Go ahead, Cannon, let's drop it in there. Let's see if we can get a good solid picture of what's going to happen. All right, Cannon, drop it in there.
Do we have to drop all of them?
So let's look. Go ahead, drop it in there. What do you notice that's happening at the top, Cannon?
It's cool. It's dissolving like water and stuff.
And let's look really close to what's happening. Let's drop some more in there, should we?
Yeah, we should.
Okay, drop another one in there. I'm wondering if you can see the bubbles and the gas that are coming. Drop one in there, Cannon. Look at the bottom.
I know.
You can see it bubbling as it brings that water up through the oil. And
Do you hear
again,
that noise?
I know. And again, it's doing that because we know that water and oil are not going to mix. So it's bringing the water up from the bottom and it's bubbling through using carbon dioxide. You want to try another one?
Yeah.
All right, so we're going to do one more because we've really got it good and bubbly over here. Let's do one more. Look at the color of the bubbles at the top. That's really cool, huh? All right, ready? Here, let me break it again for you. All right, drop it in there.
Boop.
Let's look and see. It is really bubbling. It looks so cool right now.
It
I
smells
love
so
this.
good.
It smells good. I just think this looks really, really neat. And the bubbles look really, really pretty coming up through that vegetable oil.
I'm dropping another one.
Okay, drop some more in there. If you want to try this experiment with vegetable oil, that's great. But what's really cool is if you take the same experiment and use different types of oils, you can see how they all differently react. So olive oil, try mineral oil, and things like that. So this is our lava lamp experiment. I think we had a lot of fun, didn't we, Cannon?
Yeah, let me touch it.
No, don't touch it. Again, parental supervision. Make sure you have your safety goggles, even though Cannon never actually wears his. Safety first when we're doing experiments.
Oh, that got my eye.
Oh, goodness. Are you okay?
Yeah, now I won't. See,
Now
I
it
can
won't
just
get
rub it
lost.
on my goggles.
All right, guys. Y'all have a good day. I hope you have fun playing with science. I know we do. It's one of Cannon's absolute favorite things. So, Cannon out.
Yeah, booty doop be the bop bop.